Hello there, I'm Thomas Hatsios, German-American pilot flying the Boeing 787-900 tonight flight from Zurich International Airport, gonna be flying Zurich to Switzerland, Germany, then coming back to Zurich International Airport, the runway 1449, Lszh localized and landing zone. I'm in the cockpit for the pre-takeoff preparation of the quality wings, Boeing 787-900 and Microsoft Flight Simulator X. I'm gonna start showing you the cockpit information displays and the functions of the Boeing 787-900 aircraft. I'm gonna start with the primary flight display. The displays the airspeed indicated, the airspeed selected from the autopilot to flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot and flight director system panel, the vertical rate of climb and descent of the aircraft in tens, hundreds and thousands feet per minute, all the steepness of the trigonometric angles and decrease can climb and descent. We have the radio altitude above the ground level, the artificial horizon with the altitude indicator, the pitch ladder decrease, the bank angle increase. You can see also other things like the exercise, the horizontal situation indicator with the integrated display of the flight plan. You can see the flight plan legs when you're going to be flying with the aircraft. You can see also the navigation display, the horizontal and vertical profile of the navigation display. So you can see also here in the navigation display we have the magnetic heading and track, the magnetic north pole and the geographic north pole and magnetic variation depending where we are in the world, the wind direction and speed, the range nautical miles of the terrain map. You can see the terrain and weather reflections from the weather radar with a red, green and yellow color. Also the lakes, the rivers and the sea with blue. So we have also the 4-letter name of the airports where we are located and the other airports. So we have our own airport, the Zurich International Airport, the Lszh in Switzerland. You can see also, you can see around here where we are located. We have the voice stations, the ADFs, the NDPs, we have the navigation aids, the nav aids. So you can see also the waypoints that we have, the waypoints which are horizontal and vertical navigation fixes. The aircraft we're going to have to fly through some waypoints when we fly. So you can see the waypoints also. We have other aircraft that fly around our own aircraft. Using the transponder, the ASP and AAC transmitter receiver transmits our frequency to other aircraft, and the traffic controller receives from other aircraft and displays using the radio frequency. You can calculate the other aircraft distance from our aircraft, altitude difference from our aircraft, whether they climb or descend with respect to our aircraft. You can also calculate the velocity closing in between our aircraft and the other aircraft. It will give us a warning if we have an incoming collision with another aircraft in the air. The TCAS system traffic collision advisor system. You will see all these things here in the displays, in the primary flight display, in the navigation display, also the vertical display of the navigation display. So we have also the ACAS engine indication controller system display. You can see the left engine and the right engine indications like the N1 exhaust gas temperature, N2. I will show you all the indications that we have from the engines. Also the airspeed here, barometric altitude, the vertical rate of climb descent of the aircraft in tens, hundreds, thousands feet per minute, or the steepness of the trigonometric angles in decrease. You can select from the autopilot flight director system panel flight path angle. So you have here the pitch ladder decrease, the bank angle decrease, the airspeed tape, the airspeed indicator, radio altitude above the ground level, barometric pressure setting over here 29.92 inches of mercury, radio minimums, and also the flight mode annunciator over here with the autopilot and auto throttle, lateral vertical navigation modes. We can see also the indications here from the autopilot flight director system panel with the airspeed, the heading and the altitude selected. We have also the vertical speed, the flight path angle. So you can see from the autopilot we have the same indications here: 200 knots airspeed, 10,000 feet and heading of 360 degrees. You can change later. When we fly here in the navigation display, we can see how far above the ground we're gonna be flying. You can see the mountains around us when we fly. So you will see many interesting things before we going into flight. So also in the navigation, in the primary flight display, we have the display of the Lszh localizer, the horizontal localizer, and vertical glide slope from the instrument landing system. The Lszh localizer we use for takeoff and for landing. We have the runway 14 and the Zurich International Airport in Switzerland. So you can see the Lszh localizer, the radio frequencies, receiver from the onboard antennas of the aircraft. That displays the horizontal localizer and vertical glide slope that guide you with the runway we use for takeoff and for landing, that transmits the radio frequency antennas of the instrument landing system. So we have the runway 14 Lszh localizer 14 of the Zurich International Airport in Switzerland. We're gonna tune this either manually using the flight management computer. You can see the flight management computer over here, so we'll use that to make a flight plan. Will be displayed here in the navigation display, also in the HSI. So I'm gonna use also we can tune the radio frequencies for the Lszh localizer. So we have the mouse pad here. We can line select using the mouse pad the functions here. So you see the index over here, identity, position. We can change the modes of the we can select whatever we like. I'm gonna show you later in progress of the flight. So we use this mouse pad for that. Also with this mouse pad you can select over here, as you can see, using the same thing with the mouse cursor here, as you can see. So you can select from the mouse of the computer over here the functions that you need from the flight management computer. Also here the data position, plan, navigation data. So you will see also the systems here. So we have the barometric altitude over here, barometric setting, inches of metric hectopascals, radio, baro, minimums, plan, range. Also here to change the display of the map. You can select the range and the plan or menu or map, weather radar, traffic, terrain. Also some warnings, cancel, recall, reject, and accept. So you can see also the functions here that I told you, the autopilot flight director system panel, also in a couple of minutes. So I'm gonna show you all these things about the Boeing 787-900. So we're gonna have also the flight controls here. So you will see many functions of the Boeing 787Z aircraft, like the flight controls. I will start showing you how to use the flight controls to control the aircraft in flight. Also the thrust levers. Over here you can move the thrust control using the yoke here, using the side stick that I have. I controls also the yoke. You can also control all the thrust levers like this, as you can see. So we have the engines function here. We can move it forward or aft using this switch here. So you can climb, you can descend, you can make bangles to the left, bangles to the right. Also use the rudder pedals for the rudder, the vertical rudder. The elevator for climb and descent, making bangles to the right, bangles to the left. So you have the elevator, the horizontal elevator control for climb and descent over here. Also the ailerons and the spoilers, left and right wing, the control wheel. Also the rudder pedals over here. You can use the rudder pedals for the vertical rudder over here. You can see the elevator control for climb and descent, the rudder pedals and ailerons and spoilers like this. So maybe you're gonna see later a better view of the flight control system. I use the flight controls for directional control in flight. So I'm gonna talk to you about aerodynamics and Newton's physics and aerospace engineering. you will derive some principles about flying the aircraft. So I will derive you some principles about the flight controls, also the thrust levers for the engines. Over here you can see we have the horizontal trim stabilizer. We can trim the horizontal tail of the aircraft, the alternate channel of the horizontal trim. You can see nose trim, nose up trim this way, nose down trim this way. This is fly-by-wire aircraft, so you have the trim switch. Over here you have the cutoff switch for the trim. Also the fuel control, left and right engine. As you can see, fire extinguishers, left and right engine. Transporter over here, rudder trim. So this is radio communication panel over here also. You can tune the radios, receivers, as you can see. Then we're gonna see the overhead panel, all the systems, electric, hydraulic, fuel system, electronic engine control for the engines, flight control computers. Over here you can see the flight control computer in the auto position, primary flight control computers. So we have pressurizer over here, cabin pressurization. And the control of the bleeder from the engines for oxygen regulation, air conditioning, ventilation. So you're gonna see all the systems one by one of the aircraft. Also make an engine start demonstration. We're gonna use the APU here, the auxiliary power unit, later in flight. So I will talk to you now about the Newton's physics, aeronautical and aerospace engineering, and derive you some principles we need to know about aerodynamics when flying the aircraft. So I will show you now the outside view of the Boeing 787, and I will talk to you about these things. Also we need to know for handling the flight controls of the aircraft. So you can see here, so we have the outside view of the Boeing 787. You can see the wings of the aircraft hold the weight of the aircraft when the aircraft is flying, using the lift from the aerodynamic flow of the airflow of the wings. We have the thrust from the engines, the forward thrust vector, the Z plus from the nose cone from behind the engines that push the aircraft forward. You can see we have over here the mean aerodynamic chord position of the forward wings, the Mach, which is 23% of the mean aerodynamic chord of the wings, where the maximum aerodynamic lift occurs in the forward wings is also the position, the maximum aerodynamic lift, also where the stall begins. When we fly, the airflow becomes detached from the top surface of the wings all the way up, and the aircraft starts to fall. So we need to avoid the stall speed. We have also the center of pressure, it moves forward or aft all the time over here as we fly. We have also the center of gravity over here, pretty much close to the mean aerodynamic chord. The center of gravity also is the position where we handle the yawing axis of the aircraft, the rudder over here. So you make the rudder to turn around. The yawing axis is the vertical axis over here through the center of gravity. Also we have the lateral axis from wingtip to wingtip is the pitch axis. So we can control the pitch of the aircraft for climb or descent using the elevator as we fly. So you can descend, you can also climb using the side stick or the yoke of the aircraft. So you see the elevator here. This is climb over here. This descent. So this is just the elevator axis, as much as we need. Easily, we don't need too much. We have also the rudder, as you can see, the rudder pedals. And we have also the longitudinal axis from nose to tail, which is the lateral the roll axis. the roll control of the aircraft, so we can roll the aircraft left or right using the ailerons and the spoilers in the left and the right wing each way to make right or left turn like this. So we have all coordinated flight controls this way for controlling the aircraft. Also we have here, you can see the aircraft wings. You can see the bottom surface of the wings. I'll tell you about aerodynamics for now, from the Bernoulli fluid. So you can see the bottom surface of the wings is more flat and the flaps are extended. Also, we're gonna have an angle of attack positive after takeoff when accelerate for takeoff at about 140 knots. The airflow will be moving much slower below the wings, so we're gonna be having higher pressure, which will pressurize the aircraft weight and wings up into the air. Also, you can see this is Bernoulli fluid, so you can see the top surface of the wings is more curved, so the airflow is moving much faster above the wings, so we have higher airspeed of the airflow above the wings, which creates lower pressure, which sucks the aircraft weight and wings up into the air, depending on the airspeed also. So this is the basic aerodynamic principles we need to know for flying the Boeing 787. We have also the flight controls here, as I told you, the outside view, the inside cockpit view. So we climb and we descend the elevator, the pitch axis, which is the lateral axis, the roll axis, which is the control wheel for making left and right turn, using control elevator, pitch axis and roll axis. Also we have the rudder pedals, which is the vertical tail, the rudder, and also is the nose wheel steering interconnected. In the ground we have the forward nose wheel of the aircraft over there, where it's located. If we look outside, it's below the cockpit. So you can see we have the nose wheel steering here. It controls up to 76 degrees usually of left and right turns. Also we have the rudder pedals for doing that, interconnected in the ground. It controls lower to like 7 degrees maximum deflection above 45 knots in takeoff, because we have the rudder also dynamically effective from about 45 knots and higher in takeoff. So then it decreases to 0 degrees deflection to like 76 knots. So we have only the rudder above maybe 80 knots, aerodynamically effective for making yawing turns, for controlling the yawing axis. So you lose the nose wheel steering from the forward wheels. So you have also the toe brakes in the rudder pedals. So this is all the functions. Also here in the control wheel of the aircraft, you can see we have this switch here. This is the horizontal elevator trim switch. You can trim the elevator of the aircraft when flying. As you can see, elevator trim switch. This way you trim, you pitch the nose up, and this way you pitch the nose down. So you trim the elevator up, you pitch the nose up, you trim the elevator down, you pitch the nose down. So you can see what it says. Elevator trim, left click down, right click up. So this is the main function, elevator trim. We have also the autopilot disconnect switch here, and the head-up clutter switch, the hood displays. You can see also the flaps limit over here. Some other functions, so this is a control wheel, what is doing the rudder pedals, as you can see. So we have a couple more controls here. We have for the horizontal trim stabilizer, I showed you before. We have also this, the nose up, nose down alternate channel. So So this is a fly-by-wire aircraft. It has the flight control computers. Flight control computers which can control the flight control surfaces in flight, like in the Airbus aircraft. You have the normal, the alternate, and direct mode of control of the flight controls. So you control the flight controls of the aircraft depending on the accelerations in flight. So sometimes it's not actually in the same way as you deflect the flight controls, as the flight surface flight control surface deflects is controlled by the fly-by-wire system, the flight control computers, unless you are in the direct mode. So you have the horizontal trim stabilizer, as I told you. You have the manual trim, also you have the alternate trim channel, and you have the auto trim channel. Because it's a fly-by-wire aircraft, it can trim its own self when flying using the autopilot flight director system panel, the auto throttle, and the flight management computer commands, and also the flight control computers commands. So you can see the flight control computers over here. It should be in the auto position. Primary flight control computers, yeah. You have also the flight control surfaces over here, and some other functions we will explain in another time. And you can see you have a failure of the horizontal stabilizer that is affected by the hydraulic systems here. You can see here it has L2 and R2 hydraulics stabilizer. So you have a failure of this system that is affected by the hydraulic system. You can see here you open this guarded switch for Boeing 737, 747, 757, 767, 777 and Boeing 787. You open this guarded switch from normal to cut off over here. So you cut off the auto trim function of the Boeing 787 and you use only the manual, the alternate or the normal channel, as you can see. So you always have the manual trim switch in flight. You can balance the aircraft and relieve the air pressure. This way you trim up, this way you trim down. These are the same like over here, as you can see. Trim up and trim down. Also we have the parking brakes over here. And the normal switch over here. So I will show you also a couple more things for the flight control systems. You can see we have the thrust levers, which is controlled by the side stick that I have, Lszh in 3D. So you'll see the thrust increase or decrease accordingly if we move the thrust levers. You will see the indications, or maybe we'll have a warning, we're not configured for takeoff right now. So you will see also we have the horizontal stabilizer trim position that I showed you, the rudder trim, the outflow valves, some other things, the cabin pressurization, rate of climb and descent, differential pressure, 8 psi. It can go like when we fly at 40,000 feet, it will go 8 psi. Differential pressure in the cabin altitude will be like 6 or 7,000 feet above the sea level, so it's gonna be higher pressure inside the cockpit and the aircraft cabin and lower pressure outside. We have also the flaps position. You can see also the outflow valve position. We can turn on here later, you will see. So we have the flaps position over here. So we move forward, you can see the flaps going up. So in the up position they will be retracted over here, as you can see. You can see the flaps are being retracted right now, both sides over here. And the slots, so we extend them right now. You can see we extend the flaps like this. How many degrees? Like 510 over here. You can see. Right now it's in the 5 degrees. We have also lower, we have higher extension, 17, 18, 19, 20, 25, 30 degrees maximum extent. So you can position the way you want. You will see the flaps extend over here, and also outside you see higher extension of the flaps, both sides, and also the slats in the forward side of the aircraft. So we have also the speed brakes over here, speed brake control, extend and retract. You can see the speed brakes. Like this, extend and retract. So this is this control here, this handle. So we have a few more systems to see from the Boeing 787 before going into flight. We have a couple more things. So we have here also this view of the flight controls of the Boeing 787. I'll show you one more view of the Boeing 787 flight control system. Also, you will see after the flight management computer, I will input all the data we need to make the flight. So I will show you this view of the flight controls right now, and the other one you will see a better view with another screen view, and also you can see the outside view of the flight controls. So you can see also the flight controls are interconnected, they move together. In flight, both the captain and the first officer sides move together, interconnected. Also the rudder pedals. Unless we have a failure in flight, they're not like in the Airbus, you have the side stick priority button for either left or right side. So I will show you now this view that is better, more clear view. Also the Lszh Extreme 3D over here. So you will see here you can climb, you can descend, make turns to the left, make turns to the right. So this is a nice way to control the flight controls of the aircraft of the Boeing 787. I hope you have a better view of the screen like this. You can see also the side stick that I'm using, the Lszh Extreme 3D. So also we have the thrust control over here of the aircraft of the Boeing 787. So you can see the thrust levers moving forward or aft over here to control the thrust indicator in the ACAS indication control system. Display quite easy. So this is how to control the aircraft, the Boeing 787-900. So I will show you the rest of the systems of the aircraft. You can see we have the thrust control, the side stick deflection is proportional to the yoke deflection, aileron spoilers, horizontal trim stabilizer switch over here. You can control horizontal stabilizer, also the outside view of the aircraft over here. Again, one more time. So we see we have full flight controls over here. Side stick, ailerons, elevator, full elevator, full rudder. So this is the basics of the 787. We'll show you now the rest of the systems of the aircraft. I will continue now with the flight management computers. So I will use the flight management computer to enter all the data of the aircraft for this flight. That includes the takeoff, gross weight, that includes the empty weight plus the passenger plus the cargo plus the fuel on board, where the fuel is stored in the left and the right wing, in the center tank, how much we have, 30% in the left wing, 30% in the right wing, and 10% in the center tank. So also the flight management computer is going to calculate the fuel load and the load from the passengers and the cargo automatically. Also, as we fly, we burn fuel, the center of gravity is shifted away and is recalculated every second from the flight management computer. So also the flight management computer calculates the mineral dynamic core position of the forward wings, the Mach that I told you, which is 23% of the mineral dynamic core of the forward wings. It can also calculate the horizontal stabilizer and elevator trim position from takeoff, climb, cruise test, and approach and landing. So we're going to be having 4.25 degrees of the horizontal trim stabilizer, the mineral dynamic cord, where on the maximum dynamic lift occurs in the forward wings. As I saw you, also the stall you have to monitor here in the primary flight display. When you fly, you have the airspeed tape. You can see the airspeed indicator. Also, you're gonna have the stall speed with yellow and red indication down here. So you need to have an airspeed higher than the stall speed during the whole flight, and also an angle of attack lower than that of the stall. So you will see also that how we can control that. Also, I'm gonna show you. We're gonna use 15 degrees of flaps for takeoff. We have the Zurich International Airport Lszh in Switzerland, so we're gonna select the runway 14 for takeoff. The runway length, the runway slope, the wind direction, the speed, the barometric pressure, the density of the air, and the pressure of the air, and the temperature of the air. Also the runway conditions, if it is ice, dry or wet. We're gonna have the takeoff speeds, the V1, V-rotate and V2 calculated automatically from the flight management computer. We're gonna have a pitch attitude of 9 degrees for takeoff with 50 degrees of flaps and 4.25 degrees of horizontal trim stabilizer. We're gonna have also the seats, the center instrument departure waypoints and fixes that include horizontal vertical navigation fixes and altitude and speed constraints for the initial climb of the aircraft after departure. We're gonna climb to like 25, 26, 27, 29, 30,000 feet above the sea level. We're gonna cruise and transverse through some waypoints. Then we're gonna start the descent back to the airport elevation 7 or 6,000 feet above the sea level. We're gonna have the stars. The stars have the start the terminal arrival waypoints and fixes for the terminal approach and landing of the aircraft. You will see them also, and airspeed and altitude constraints. So we have to follow the stars for the terminal approach and landing. So you'll see also that. So we're gonna have the stars, and we're gonna align with the horizontal stabilizer. We're gonna align with the horizontal localizer. We're gonna use the Ilsloc localizer system. We're gonna have the vertical glide slope and also the horizontal localizer, the radio frequencies transmitted from the runway threshold antennas received from the onboard antennas. You will see the localizer. We're gonna align the aircraft with the magnetic north pole heading of 136 degrees of the runway for approach and landing. We're gonna have about 35 to 30 degrees of flaps extended for approach and landing. Also, we're gonna be having the landing gear down and about 160, 170 knots or 250 to 170 kilometers an hour for approach and landing. So you will see all these things. Also, we're gonna have all these things. We're gonna have a complete flight plan or flight path or route. You will see now how we'll use the flight management computer over here to create the flight plan. So we go in this view, control quadrant. You can see I'm using the mouse pad here to control all the inputs here. So this is a nice view of the cockpit over here. So we have, as you can see, Identity, position, performance, takeoff, approach, navigation, data, flight plans, loader, traffic control, load plan, save plan. So this is all the modes we can use over here. So we have identity, it's Boeing 787-900, the engines, GNX engines, 1B14 Iraq cycle. So we have position here, Lszh airport in Switzerland, which also we can use to align the aircraft with the inertial alignment, inertial laser gyroscopes alignment if we need. I would say later. So we have the performance here, 0 fuel weight plus fuel on board. We have the gross weight for takeoff over here. We have the cruising altitude, cost index, fuel, freezing temperature, and the cruising center of gravity in flight. The reserve fuel on the step side. Also, we use the first the route departure origin here. From this airport back to this airport, you can see the route is displayed with blue is not yet active. So we copy paste, we clear and runway 14 over here. So we have departure and arrival over here. We can use runway 10, 14, 16, 28, 32 either runway. So we're gonna use runway 14, Transzui to Alpha over here, and we have departure arrivals. Now we set the arrivals. So we have VOM 16, VOM 28, VOM 34, ILS 14, ILS 16. So we have ILS 28, ILS 34, GLS 14 localizer, 28 localizer, 34, and the stars in the left side. So we can use ILS 14, instrument landing system 14, Trans-Amity, Trans-Negria 1 Alpha over here. So we have the legs, departure from the first waypoint, heading of the runway to nautical miles, then the second one, 1, 3, 5, 6, as we climb one by one to the cruise level, then descend, approach and landing. So we have discontinuity, cancel, the starts here. So you will see now how we're gonna activate. The route is with blue again, and it's not showing the purple. So we have 0 fuel weight plus fuel on board, gross weight for takeoff over here, reserve fuel 5%, and the cruising altitude 25,300 feet. Over here, cost index 100%, as you can see here, 100%. Cruising fuel temperature, freezing, center of gravity, -37 degrees freeze, and cruising center of gravity, and cruising altitude. So we execute here this, we activate the route. So we have the first waypoint, 135 degrees heading to nautical miles, 250 knots, 1900, turn 1 nautical mile, then 3 nautical, 5, 6 nautical miles, Zui 062 heading 301 knots, 6000 alpha. Negria 26 nautical miles heading 071, 301 knots, flight level 22,200. Then we make a right turn to left nautical miles, 320, 11,800. Descent for approach after that. Pneumatic 12 nautical miles, 230 degrees, 11,800, 258 degrees, 6 nautical miles, 190, 10,400. The Amity Zui, 9 nautical miles from Amity, 180 knots, 7,000 alpha. Then Z8 701, 108 knots, 6,000 alpha, 6 nautical miles. TRA 10 nautical miles, 290 degrees, 180 knots, 5,000 alpha, 235 degrees, C114, CI14, 6 nautical miles, 184,000 alpha. Oznem, we make a left turn here, 136 degrees, 5 nautical miles, 174,000. Runway 14, 136 degrees, nautical miles, 140, 1,455 feet, and we have takeoff ground. Initialize here also the flaps used for takeoff, flaps 15 degrees, center of gravity trim 23%, or 4.85 degrees horizontal stabilizer, and the takeoff speeds V1 V-rotate, as you can see, V1 V-rotate and V2. We have gross weight for takeoff. So we use also initialize, route, departure, arrival, alternate, VNAV, progress, FMC, communications, hold. You can select a waypoint and hold over here, as you can see in flight. Use a fix, radial fix, and the navigation radio. So this is all the things we need to do. So you can see we have here the display of the navigation aids over here that we have. The flight plan created. So I need to talk to you a little bit. The flight plan, we have the takeoff here, this runway. We're gonna climb, cruise. You can see also the climb rate here in the displays. Also, you can see we can set the ranks over here. We have FIR here, airspace. So you can set the range higher, further away from you. You will see more airports, you will see more waypoints as you fly. This is the waypoints we have selected here in the flight management computer, or as displayed here in the display that we have to fly through. This route also climbed. You can see the aircraft is going to be climbing here, how far above the ground it's going to be. You can see also we have the display of other airports. Here is Germany, as you can see. Here is France, and this is Switzerland down here. So we have the range here. Also the center display over here, 360 degrees view. So we can use this for takeoff and for landing. We have also a display from the GPS. You can see the runway we use for takeoff, the taxiway, the aircraft position, the terrain elevation, the range here, and the ground speed. Lszh, it's the airport that we are located. You can see the terrain in front of you also. As we're gonna be flying, we have to avoid some mountains. So you can see we have the taxiway in front of us, and the runway on this side. Also the other side you can see is the same as displayed here. As you can see around you, when you look around, you have the taxiway and the runway from the GPS over here. So we have also this display, the plan, a couple of minutes. You can see map centering, the airplane, elevation of the terrain. So this is the runway again, we can use for takeoff and for landing, for alignment when we flying. You can see further away. Also the runways, actually the waypoints over here, from climb over here, and then descend up towards landing the stars. So we further away, Nigria and the other airports. So this is for the navigation purpose only, the display. So we're going for takeoff in a couple of minutes. So we're gonna set also the autopilot, the airspeed, and the barometric altitude, target altitude, heading. You can see also the display here. The HSI displays a few things, as you can see. So we're gonna set the autopilot flight director system panel here. As you can see, we have the autopilot engage and disengage switch over here. The auto throttle left and right, engage and disengage flight director. Also the airspeed, we can set the airspeed guidance of the aircraft, so we can change to whatever value we need for flying the aircraft. After takeoff, we're gonna have this. We have also the LNAV and VNAV function, as you can see, as displayed from the flight management computer. If we turn off the flight director, the LNAV VNAV disconnect, we cannot use it. So we have autopilot engage over here, autopilot disengage, flight level change, climb continuous and auto throttle, bank angle, automatic, or select how many degrees. It has typical bank angles we make. We set the heading, magnetic north pole heading 136 degrees for takeoff and for landing. Heading track, hold, we have the altitude also. So we set the altitude for flying. Over here the aircraft we can set, and also hundreds of feet and thousands of feet. So we have vertical speed, flight path angle over here. You can set like for a descent over here, you'll see the minus display, or you can set level off or a climb. So this is now for climb. So we can set everything here. So we are almost set for the takeoff. We're gonna make an engine start demonstration, and one last thing to show you the engine's indications. Then I will show you the overhead panel. So you can see here also from the overhead panel we have the cabin pressurization here display. So we're gonna make the engine start demonstration. So you can see the engines here. We have the GNX engines that display the N1, which is low speed starters, have low pressure comparison to one of the turbofan engine left and right. The exhaust gas temperature engine N2, which is the high speed starters, have high pressure compressor into one of the turbofan engine. Fuel flow per engine per hour 1000 kilograms, 1000 pounds, oil pressure, oil temperature, oil quantity, and vibration of the end stage of the engine. Also the outflow valves position, gross weight, and the fuel and the temperature of the fuel right now. Fuel temperature. So we have many things more to see. So we have the FAREX. The FAREX are the full authority. This is electronic control computers. One is called parents gearbox, called channel redundancy. If one channel fails, the other takes over. Controls monitors displays all the engine data. I just show you also when we climb into higher levels the aircraft. Like 20, 30 or 40,000 feet above the sea level, like 9,000, 10,000, 11, 12,000 meters above the sea level. Also climb higher, the pressure of the air and the density and the oxygen level become less than half than that of the sea level. Also the temperature of the air is becoming freezing, minus 30, minus 40, minus 50, minus 60 degrees below 0 Celsius. Also the aircraft will be flying with an airspeed rate like 2 or 3 times faster than that of the sea level, so we're gonna have a higher intake of airflow of air from the front fans of the aircraft engines for compression and combustion, also for fuel and mixture. So the fuel mixture adjustment is made automatically from the FAREX. Over here when you move the thrust levers, you command the engines automatically. So the FAREX also control engine start and side out. As I told you, fuel mixture automatic, and also the circulation of the fuel, oil and lubricant from the wing tanks of the fuel when we flying is gonna be freezing at minus 37 degrees below 0. So we recirculate whenever it's needed automatically again from the FAREX using the recirculation from the fuel tanks to the engine components to heat up the fuel and cool down also the engines, and it's doing the same for the lubricant and the oil. Also the FAREX controls the pressurizer from the 5th and 9th stage of the cabin of the engine's outflow valves, which is also supplied for cabin pressurization, wing engine anti-ice, air conditioning and ventilation, also for the hydraulic fluid tanks pressurization. Also from the bypass stage for the packs. So you can see here we have the APU. We're gonna start the APU right now very quickly. You can see we have the left and the right IGZ, the great drive generator. I will show you later in the display. Battery 120 to 200 volts for 100 Hz frequency. Primary flight control computers in the auto position. Air data computer over here. I'll show you later. Flight control surfaces. Over here, towing power, FD door, passenger option, window heat over here, hydraulics, left and right, engine driving. We turn off, you will see what it displays, then we turn back on and then to the auto position, primary in demand. You can see also we can engine the ice over here. We have also we have the recorders here, cargo and APU fire. We have the electronic engine control for the engines with the auto start system, normal and alternate mode of the engines control, flight control computer. So we have we can run this to jettison some fuel in flight, lose some weight, select the nozzles and how much remain. We have the fuel booster pumps left and right wing, The crossfit valve, if we turn it on, it can feed either engine with other pump, or it can also balance the fuel between the left and the right wing. So we can use either valves whenever needed. We have also here cabin pressurization. In the manual, we have the outflow valves control when climb and descend to pressurize or depressurize the aircraft. Also the packs from the engines from the APU. So you will see now, last thing to see before going for takeoff over here. We have also the lighting system. So we have here the systems display here. So you can see all the systems. We have hydraulic, APU, oxygen, liquid cooling, the electric over here, left and right engine, IDG, controller, drive, 100 volts, 200 volts, 400 Hz frequency, APU, main battery voltage 31. Over here, hydraulics, left engine driving, right engine driving, electric C1 and C2, 5100 psi. Over here, where the hydraulic fluid goes, with system usage, fuel, you can see left and right wing, center tank 11,000, 11,000, 11,000, total 73,400. You can see low and high pressure fuel valves feed both engines from the center tank. The crossfit valve is off, but we will turn it on, can feed either engine with other tank or either pump. The APU is fed from the left wing is the DC motor. Also here you can see we have the minimum fuel temperature, below which the fuel is freezing, minus 37 degrees, minus 6. Also the electric, I forgot to mention, we have here the batteries. You can see here battery voltage, better view. So we have the fuel air system, packs, left and right engine, APU, doors are closed, the cabin can be pressurized, the landing gear, temperature of the brakes and pressure of the tires, flight controls over here. So we use the flight controls of the aircraft. You can see the movement is correct, there is no problem. Also the tail for climb and descent, the horizontal string stabilizer, airfield display over here, status, maintenance systems and circuit breakers. Again, and last thing to see the checklist, normal menu, what to do before takeoff, after takeoff, descent, approach, landing. So we have the navigation again display over here. We turn off both engines like this, and we have a couple of minutes more to go for flight. So we turn off both fuel control, left and right engine driving. You will see that the engines are going off like this. So we turn off both engines, as you can see. So we go over here, turn on the auto start system. You will see the reconfiguration, yellow amber lights. So we have only pressurizer right now from the APU to start the engines here. You can see the N2 is increasing. We have no fuel flow right now, so at 20% we have enough pressurizer. We can turn on the fuel control here, left and right, both of them. So we see we have the auto start on right now, it's kicking in. So we have 28, 29, 30% of the auto start system. So you can see the engines are starting, 40, 49, 50. So we're gonna have the running engines in 1 minute, actually in a couple of seconds. So we have running both engines, and maybe in 1 minute we're gonna be airborne. So we have the flaps up for takeoff at 15 degrees from 30. So we taxi into the runway, we take out the clearance from the air traffic control and use the tiller for steering for the nose wheel. So we have here We align now with the runway very quickly, as you can see. The runway center line. Once aligned with the center line, we can add some thrust over here for takeoff ground. So we hold the yoke down to pressurize the nozzle and use the rudder for alignment. Rudder pedal left. We have 80 knots, 100, 120 V1 over here, 130. We rotate. So we rotate 9 degrees or less. Pitch altitude for takeoff. So we have the maximum takeoff power over here. So we have the climb of the aircraft, as you can see. You can see the airspeed indicated 183 knots, the wind direction speed, the stall speed below the airspeed. Also we climbed, we are 2000 feet above the ground level, 2100, 2200, 300, 400, but 3900, 4000 above the sea. We climbed with 4000 feet per minute over here, as you can see. Also you can see over here we are just like 2000, 3000 feet above the ground. You can see the terrain below us displayed with green. The flight plan we have to follow, the modes, the engines function over here. Also we use a little bit more range, increase the range. You will see more colors, red, green, yellow over here as we climb. So we need to follow the flight plan right now. As you can see, landing gear also up, retracted. So you can see the Switzerland, the view as we climb, and we need to make the turn now for alignment with the flight plan. So make the turn here to follow the flight plan. So this is the view of the cockpit after takeoff, as you can see. Also here, the view outside. Hope you like the beautiful view of the Switzerland. So this is the beautiful view of the Switzerland as we climb out from the airport. Hold, keep climbing, and we have 12 more minutes for the video to end. We need to cross through this waypoint, the intercept. We here make left turn, but we can override it and fly for the Zui. You can look also further or closer with this view also, navigation display. You can see the whole flight plan right now as we're gonna be flying through the waypoints. So we can leave the hands off from the flight controls, there is no problem. The aircraft keeps flying very well by itself. for as long as you wish, as we are in a climb and properly trimmed with full thrust. So we have here, we need to turn, so give us a signal to make some turn here, I believe. We need to make a left turn. You can see also the head-up display, and we have 12 more minutes for approach and landing. The autopilot flight director system panel, the thrust levers. So this is the flight controls and aircraft controls after takeoff. So we need to make some turn here, small turn. You can leave off the flight controls, no problem. Of your hands, the aircraft keeps flying the way it should be. As you can see, it's not falling off the sky. So you can control like this, hands off without the autopilot, and you leave the flight controls off, and the aircraft keeps flying its trajectory, its flight path. So it's quite stable to flying on jet aircraft. I like flying only jet aircraft. So thank you for watching me, my flight. So we climb through here. $18,000 feet. We need to climb a little bit higher and have like 10 more minutes for this flight. As you can see, the view of the cockpit also. Need to make a small turn here to align with the flight path heading. So maybe we're gonna start the turn now. You can see the galaxy, we're flying much higher now. We are 20,000 feet or 7,000 meters above the sea level. So we have also the lakes here, beautiful lake, the Germany, Bayern Munich, my homeland here, and the France, the galaxy, this beautiful crescent. So also the Switzerland again. So we're gonna start the turn now. We're going back to the airport. Keep climbing a little bit more. So make a swift turn over here. Again, we leave the hands off from the flight controls, no problem. As you can see, this is the turn on the flight plan. So this is how close we get to my homeland, Germany, as you can see. This is the Boeing 787 jet aircraft, beautiful. And we keep climbing the lakes, the Switzerland and the galaxy. So make a small turn and we need 8 more minutes. Press a little bit down, keep climbing, 32,300 feet. Oh, we have the chemtrails, so we also need to pull up this here and leveling off, as you can see, and we have the chemtrails now. Beautiful view of the frozen vapors here, overflying the Germany, the lakes over here, the France. Boeing 787, the galaxy, and now the beautiful view of the star sign. So we're gonna make a small turn here. This is how beautiful the view is from here. 35,000 feet. So here we are, we reached maximum climb altitude, and we're going back home. We need 6 more minutes for descent and approach. So we start the descent over here from this altitude. We retract the flaps and we descend. We're gonna increase the airspeed, as you can see. We still have the chemtrails over here as we descend. So we need to descend a little bit faster. So increase the airspeed, decrease the thrust levers a little bit, and speed brakes. So we follow the flight plan like this as we are descending for approach and landing. So we keep descending. We make the turn now for approach and landing as we descend, and we have 4 more minutes. As you can see, a little bit left rudder over here as we make the turn for approach and landing. A little bit more thrust also. So we descend now for approach and landing. We have to use some alignment with the runway heading as we descend. Landing gear down also. Flaps. So we have 2 more minutes for approach and landing here, as you can see. So we align here with the runway, and we need a couple more minutes for approach and landing. As you can see, add a few more flaps also. So we have manual flight controls now, as you can see. Use a little bit rudder pedal because we have side wind over here. We have a lot of side wind and wind gusts, so we need to align with the center line using ailerons, control wheel, aileron spoilers, and also a little bit rudder pedals. So you can see how we descend. We have also the Lszh localizer here, as you can see. So we use idle thrust now. And increase the rate of descent here. So align with the start zone. We have the flare over here, flare for touchdown. So this is the flare, touchdown, beautiful touchdown. Parking brakes, thrust reverse, and idle thrust and thrust reverser over here. Align a little bit with the center line, as you can see. So made a very beautiful landing, as you can see here. All landing gear is safe. Every part of the landing gear. So you can see the thrust reverse. We can